Good afternoon, good evening. This is Ankush here from Alif Consulting. Welcome back in our partner enablement video series. Today we will be going to talk about Zero Trust Network for a web application with Azure Firewall and Application Gateway. Here is agenda of our today's video. So we're going to understand what is a Zero Trust Network is, what are the benefits, what are the use case, how we can implement that, and what is the main principle of Zero Trust networking. And then we'll be going to walk through with the one of the reference architecture. What are the components is there, how the communication is between going to be happen, and how the digital certification is going to be there. Now let's understand what is the zero trust security is or zero trust networking is. So zero trust networking is the IT security model that required a stick identity verification for every person and the device trying to access the resources on a private network, regardless of whether they are sitting within the network or without outside the network. So zero trust networking is the main uh, technology associated with the zero trust architecture, but zero trust is the holistic approach to network security that incorporates several different principles and the technologies. Traditional IT security trust anyone and anything are inside the network. A zero trust architect is no one and nothing, right? So thing is like what exactly happened with the zero trust security is where you're not even trusting the users basically, which is known and which is coming from the inside the organizations. So you are putting up the controls on top of all the resources which you have inside the network, and all of those controls are even validating to all the users which are coming from your trusting network as well. So that's how zero trust security or zero trust networking work, right? So what are the benefits? So there is a few benefits are there. First, a traditional security module such as a depth and defense have a historical force protection on the network parameter, right? Which eventually what happen, like this provide you the defense in depth for all the resources which is there and all the attacks which is coming inside the organization or inside the resource. So let's say if there is any brute force attacks happen, or in case of any snooping is happening, if someone is sending a malware on the email, that's where when you putting up the zero trust network module, that's where you can basically have that protection in place and provide the benefit of protecting your all the resources or all the services inside the organization. Okay, and then again, so what happened with the zero trust networking is so all of these attacks basically which is coming inside the organizations or did by the outside the people or inside the people or all the employees inside the organization, zero trust take always access of these from anyone and everyone until the network can contain who you are. Then it continue monitor how you are using the data and potentially revoking the permission to copy the data elsewhere. So let's say if there is a user, right? So first example where I've seen like where I've told you like any attacks or any exploitability is some kind of brute force attack happening inside the organization or outside the organization. That's where zero trust networking come in place and help you to protect in that kind of scenario. Another thing is what happened with the zero trust networking is it's always uh, take or always understand who is coming inside, what he is doing, and he's providing the access and he's monitoring everything whatever that person is doing. In case of anything wrong happening with through that user, it's automatically revoke the permission of that specific user. What is the use case? Yep, definitely there's a lot of use cases there. First, the zero trust security module ensure a security breach have taken in place at this time and that all entity are miscellaneous until proven otherwise. Zero trust module use cases limited to access uh, employee working in the remote branch and home to have the organization IT asset. Third, a organization, third-party contracts, partner, and customer may require access to the IT asset, and it's also important to limit what they can access and where they can go inside the network. Now, see, if your infrastructure is there or if the IT system is there, it doesn't mean like you can openly go ahead and allow everyone access to that, right? Even if there is an employee which is the inside the organization, you have to provide the restricted access, and only the access uh, for which they need to access or what kind of operation they need to do. Second, if there is any third party contracts or partner or customer which may require the access to your infrastructure to do, certain kind of work, or certain kind of deployments, it doesn't mean like you can give them access of everything. You only need to limit the access, or you only need to give the access for the resources, or or the level of access which they only require to do their work. Organizations seeing a zero trust security posture must segment in their network to isolate their insecure IoT device. So this is something is also very important. So IoT is always connected over the internet or on the network. So you need to make sure, or zero with the zero trust security posture, you can also protect IoT devices as well. The main principle here, yep, definitely there is a three main principles in the zero trust networking. First, less access. Uh, what that mean is like you are going to give the access to the people who need the access, only the limited access, for what they need to do and for the limited time. Second, micro segmentations, dividing net upon a network into a segmentations with the different access credentials. So it doesn't mean like with this one, what is exactly going to be happen. Let's take an example where you have a multiple network devices, and it doesn't mean like you can go ahead and have them. Have a one credentials to access all the devices, right? You need to do a segmentation and having a different access credential for all the device on the different levels. Third, data users control limit when people can do with the data once they have given the access. So again, this is again a very important step or very important main principle where you need to basically control the limit of how much data they can use, right? And what exactly they can do. So there is a limit you need to put on the users, and which basically can allow you to basically restrict them what they are doing it, what they are downloading it, and what they're copying the data from for their system to outside the organization, or maybe on the other third party services. So that's where you can basically control the things. Another thing is like you can control or you can put the restriction on top of connecting the external devices, emails, and all your cloud apps which is there. So these are the main three principles which are very important for zero trust networking. Another thing is continuously monitoring, examine how users and identity are interacting with data, even and even other systems. So you have to basically continuously monitor, do the monitoring of your or the data, or do the monitoring of how exactly a system two systems are getting interconnected to the each other, or how basically the other users or entities are interacting with that specific information. So these are the main principle. So ultimately the thing is you have to put a very granular level access of to the users or to the everyone which is there, or inside the organization or outside the organization, or you need to do a end-to-end monitoring of all the data transfer basically which is happening inside the organization and outside the organizations as well. Well, implementations of zero trust networking, yep, there is the few considerations which you need to make. First, uh, consider the technology you will need to add in your current stack or current network, such as next generation firewall, zero trust network access, DLP, which is a data loss prevention, and continuously monitoring. With the firewall, basically what exactly is happening, you will be going to get network protection, data encryption, decryptions, and can also help you to do the micro segmentations, where you can basically create multiple subnets for prod, stage, UAT, and segregating them based on their network. Second, zero trust network access, which provide you to give the access to the users or a co-worker over the VPN to specific private apps with the limited one. Third, a DLP, which is a data loss prevention, help you to protect the data. You can put the policies what kind of data is need to be protected, and DLP will be going to protect whenever a user is going to send the data. The DLP doesn't will be DLP is not going to allow to send those users send the data from the user to outside. Third, continuously monitoring. Yep, you need to continuously monitor your environment and your systems or end user activities, whatever their activities doing it, and that's something is very important, because with that monitoring, you will be going to understand what those users are doing it, and what kind of data or what kind of interaction they are doing it outside the organization. Understand the access is a third, and consider your culture is the fourth. So these are the implementations of zero trust networking or zero trust access, which you need to basically consider it. Well, let's talk about the reference architecture. So in the reference architecture, you will be going to see, like, I have the application gateway, then I have a firewall, and then I have a virtual machine. So it's just a pretty much simple, but this is not how actual zero trust network looks like. Zero trust network is a combination of multiple things. This is just a reference architecture. It is one of the example where it's have shown you how you can limit it or restrict the access for your specific application. With this architecture, it support a three level of or three ways of network designing. First, a traditional hub and spoke. A second, network with using the Azure Virtual WAN as a platform. Third, a network with using the Azure Outer Server to simplify the dynamic routing. So these are the network topology which you can use with this reference architecture. Well, what are the key components here? Yep, there are a multiple key components, but let's start with the few. First one is the application gateway. Yep, application gateway is the one which basically is working as a reverse proxy and providing you the layer 7 protection on all the requests, basically, which is coming inside the applications or coming inside the organization on the cloud. And this can help you to protect any kind of attacks which is coming inside or coming to the application gateway. And also it's to provide you the SSL, which you can enable the HTTP communication over the application gateway. Second, Azure Firewall Premium is a flagship product. It's also work as a normal firewall which you eventually use with the on-premise. It's fully scalable with this firewall, basically, which we are talking about. It provides you the lot of features like IPS, IDS, restrictions, controlling the traffics. All of those are already there. So with this one, what is going to be happen? Whatever the traffic coming inside or going outside, the firewall is going to be scan that, and accordingly it will be going to control or put the traffic. Is there any virus attacks or antivirus viruses coming inside the organization to the firewall, and firewall sense it like it's not a good data, that by default it's going to be blocked on their level, right? uh, s- like how another thing is like how Azure Firewall Premium and RAM resolution is going to be happen inside the architecture. Uh, when checking for a malicious traffic, Azure Firewall verify the HTTP header matching the packet IP address and the port. For example, suppose application gateway send the traffic to the IP address, which is 172.16.1.4, and the TCP port on 443. The value of HTTP header should be resolve the IP address, right? And the second, HTTP host header usually don't contain the IP address. Instead of that, header contain the name that's match the server digital certificate. In that case, Azure Firewall Premium use the DNS to resolve the host header name to a IP address. That design determine which DNS resolution work best, as the later on the section described. So the thing is like how exactly the Azure firewall is going to sense the request, basically, which is coming from the application gateway is correct. So it's basically examine the header, and it will look for the port, and it will look for the SSL communication information. It will look for the SSL information, which is a certificate, and it will be going to look for the server IP addresses. And based on that, it's going to resolve or going to resolve the request through the DNS and sending it back to the application server. Well, this is how your digital certification going to be work. As I told you, whenever you do HTTPS communication or end-to-end end-to-end HTTPS communication, you need to have a valid certificate. So here, if you see, this is how your certificate is going to be work. On a first primary level in the application gateway, you will be going to have your public certificate with the application URL. In a firewall, you do can have your own certificate or a self-sent certificate for the Azure Firewall or virtual machine. So here it's showing as a Azure Firewall CA and the DZ cert. But the thing is, let's take an example. You do have, options inside the application gateway where you can use your certificate from your own CA authority, which is integrated with the Active Directory and its internal CA authority. Those things can be also used for internal end-to-end communication. With this digital certifications, what is going to be happen, like all the communication coming inside the application gateway till reaching to the server and coming back to the application gateway is going to be happen over the SSL. Well, let's move to the demo. So in the demo, I would be going to show you. I have deployed a one application gateway with the one server. Although I don't have any SSL enabled there, but I will be going to show you how exactly application gateway work. Now, if you really want to go ahead and have a deep dive on the application gateway, we do have created a video. There's a link in the descriptions. Please go ahead and check out that. Well, I am on my Azure portal now. So if you go to this resource group, which is Alif demo. So in this one, I have a virtual machine. I have application gateway. So in my application gateway, I have configured the firewall, which is a WAF. It's in a detection mode. We do have two things. We have a prevention or detection. So I'm directly putting in a detection mode, and then at the same time, I do have the WAF enable. And with this one, if you go on overview, you will be going to get a one public IP of this firewall, which you can use, which you can not for firewall, sorry, for the application gateway, which you can use to access the website. Now, if you click on hit one, this will be going to give you the backend server page. Now, how the communication is going to be happen? Like it's sending the request to the application gateway. In application gateway, I do have configured the backend pool where I have associated the server, and then I have created a rule in which I'm defining it what is the front end and the back end going to be. So in front end, the listener is the one which is the public IP, and then in the back end, I do have a backend pool and HTTP setting created for the application to the access, right? And now I do have an option to enable the SSL settings since I don't have a SSL certification here with me, so I will not be able to use it. But at the same time, if you really want to have that, or having it with the application gateway, that something is doable, right? And you can go to the HTTP setting, and here you can specify to HTTPS, and you just need to give it the certification here, the SSL certificate here, and you would be able to use that. Now, this is again one of the selling point, right? How you can sell the zero trust networking to the customer. So as I told you, with the reference architecture or with our previous slides, where I have told you the zero trust networking is going to be a very important part for a customer where you need to do the granular level of access, and that something is required a lot of policies in place and a lot of I can say a control in place. So the selling point is going to be like if there is a customer who is already had a breach inside the organization or outside the organization, that's where zero trust networking is going to become in place, or people who or the organization who really want to implement the zero trust. So there is a lot of options available on the Azure which you can implement, like having the application gateway and having the firewall, or having the privilege identity management, having the conditional access from the Azure AD, and and then having the private access enabled on the VM, having the encryption and end-to-end encryption. All of them are including with for the zero trust networking. Now, in my case, I already have the application gateway, and you will see that this application gateway request is getting forward to the backend server directly here. So in this case, my server is not directly interacting or coming on the internet. It's application gateway who is basically allowing the access to the backend server over the private IP, and uh, and all the communications basically taken care by the application gateway. Well, that's it in a demo. I hope you like this video. If you like, please click on like and subscribe for more upcoming videos. And feel free to reach us if you have any questions. Thank you.